Can you see if the stream is live? If it's up on the Gaslight Live thing? I think it is. Hi, Internet.
I don't know how YouTube works.
How what? I don't either.
It's like habit screwing on you.
That's exciting. Is it though? No, is it really live?
About 5 seconds behind.
Okay.
When will then be now?
Soon. This is going to be,
It's just you,
yeah, wait, and the screen, right?
not the screen.
Oh, no. Hang on. Yeah, there's like a pretty big delay in there.
It's like 30
Come on, this isn't Twitch.
so I'm still waiting.
Oh, we'll stop. This is mostly going to be like informal. I don't like have slides or anything.
You can watch in the past. Oh,
So,
you just walked by the camera.
so for the work that I'm doing in Elixir and nerves with insulin pumps and all of that, I've gotten very familiar with packet radio in the sub-gigahertz range, like the 900 megahertz range. And there's just a lot of people doing a lot of work with this, but not a lot that I can tell in Elixir. And so I thought it would be kind of fun to catch up everyone here on like just packet radio in general. So there's nothing like specific to insulin pumps with any of this. There's a couple of hex packages out there that you can use that if you had these chips, you don't have to do it. You wouldn't have to have like an insulin pump with you. You could just have a couple chips talking to each other. And I thought it would be kind of fun to demonstrate a little bit of that. And also talking from one kind of chip to another chip using the same protocols and stuff. So the primary one, the one you can actually buy is this RFM 69HCW. And SparkFun has it, Nativefruit has it. And it's like the most versatile little $15 chip I think I've ever seen. You can do on-off keying and then FSK. I can't remember what FSK stands for, but basically like really fast Morse code or the other thing. And I only care about the really fast Morse code version, so I didn't even bother thinking. Or, really fast Morse. Yeah. But these are really cool. They use SPI. Excuse me. They use SPI to communicate. And that's like 4 pins, so it's the MOSI, I don't even know if I'm pronouncing these right, but MOSI, MISO, the chip select, and then there's like some other things, like there's an interrupt pin that if you're receiving data according to what it understands to be data, and it's not just noise, it can fire the interrupt pin so you know that you're getting data and you don't have to sit there and pull for it forever. So there's some kind of cool stuff on here for as cheap as these chips are. You can integrate them pretty easily into a project. Yes?
Can I ask a really probably naive question?
Yeah.
So what's the difference between like this and like a Raspberry Pi?
Well, so this is just the, here, let me cut.
I don't understand hardware.
Let me cut to the tape. I'm going to go to the tape. Ready? Huh? Oh, you know my fingerprint. Kidding. Bad jokes. So this is what the chip looks like when it's very badly prototype soldered onto a prototype board. And then underneath it is actually the Raspberry Pi. And so it's connected via a serial connection called SPI. So you basically can communicate with the chip as a Raspberry Pi. So the code is running on a Raspberry Pi. The chip itself is just taking commands from, usually it's a microcontroller. In this case, it's the Raspberry Pi's microprocessor. So I have two of them. I have the SparkFun one, and I have the Adafruit one. And I bought these sort of speculatively, didn't know if I was actually ever going to do anything with them. And then there's a guy who's actually building some chips specific to like closed looping. And this is the chip that he chose to go on those things. So I've learned a lot about how they work. I've also got these other ones that are Texas Instrument chips. And they're, well, it's not going to focus. They're a lot harder to come by just because they're harder to integrate. They're tiny. And so most people are going with the RFM-based like breakout board thing. But the cool thing is that this one, even though it takes like a special firmware and you have to flash it with it and everything, with the specific like protocols and how to, it's the packet format and everything that it has to know about talking to insulin pumps. The other one, this RFM chip, is like almost infinitely configurable at runtime. So there's no firmware that you ever have to load on it or anything. You just have to configure everything at runtime, which also makes it a little bit harder to deal with from code. Yeah, a little bit. So there's these two projects that are out there. One of them is Elixir RFM 69. There are a few people that I know that have actually worked with the chip already, but they all had to do it behind like NDAs, and they couldn't open source any of the work that they did. And so I was kind of hoping that I could bootstrap some of that like community support by making one of my own and then telling people, and if they have experience with it, helping with it. There's not a lot here that's specific to the project that I'm working on. There is, however, one part of the code that expects it to be null terminated. Let me see if I can find that really quick. Yeah, so it basically reads until it finds a null byte and it's over. That's not a requirement of the packet communications, that's just the protocol that I'm using. And so there's a couple things that I would like to remove out of here, but I'm waiting for somebody else to be interested in it before I do that. The other half of it is this subgrf SPI, which is the firmware that gets loaded on the chips from Texas Instruments. And it has a lot more smarts on the chip itself, so I don't have to do as much to communicate with it. And I also communicate with it over a UART, so it's just got an RX and a TX pin. I've also got one that communicates over SPI. So there's like all these protocols and all these chips, and I'm trying to manage the complexity of supporting multiple boards. And the reason that I'm doing all of this and going deep with like the chips that talk to the pump and not going higher with like the algorithm or anything like that is because there's really no options right now for the Raspberry Pi for people who are trying to do this, but there are two people who are building hardware like right now. They're in their dev testing prototyping phases. One of them uses that Texas Instruments chip over SPI. The other one uses the RFM chip. And so I'm like, well, I kind of have to like figure out how to support all of these things when they come out of the gate anyway. So I've learned a lot about packet radio, and I've also learned that I really know very little about packet radio, and that's okay. Any questions? James, you made a noise that made me think you had a question.
I'm just thinking about like this wireless communication. It's probably what's stated that you could use whatever protocol over the wireless, the packet.
Mm-hmm. Yeah, you can. Yeah, you could, so the packet radio kind of acts like the lower levels of TCP/IP, right? You could build ACking and NACking structures. In fact, the RFM chip by default, I'm going to override it with our configuration, but the RFM chip out of the box has retries. It has what's called data whitening. It does like the 4x6 encoding where it takes a nibble and turns it into an even number of zeros and ones in 6 bits so that it's using constant like transmit power, but it's also not holding ones or zeros high or low. Like it's not taking up basically the available time with all ones or all zeros and setting like potential clock differences into play and things like that. So there's a lot of stuff going on, I think basically built onto that chip that if you just used it out of the box, you'd get for free. I have to do it in software because of some specific things about what I'm doing. But
what's the range on this?
I haven't tried that yet. I haven't actually tried playing with that. There's a lot of things that you'd think that I would have tried, but I haven't. In fact, the first time that I actually got a chip talking to another chip directly was last night. So this is all relatively new as far as that goes. It's always been talking to the pump and getting information back from that. So like listening and waiting for something to come was not something that I was really even thinking about when I wrote the code. It's kind of cool that it worked. I'm just going to say I wasn't expecting that entirely. So if I can like just draw a quick diagram of sort of what I'm doing with the architecture in terms of the hardware stuff. The chips that I'm trying to support they all have names. There's a slice of radio. There's one called the Explorer board. I'm calling this one's Eric's chip because I don't actually know what he's calling it. So, but these are all the different ways of connecting and the different firmwares or chip types that are happening. And we'll get to this maybe a little bit later if there's time. But the problem that I'm having is that I would like to auto-detect which chip is connected and via what mechanism when my nerves application starts. Start potentially a different supervision tree with different configuration based off of the chip that it finds when it boots up without making you have to pick which one it has. So these boards all have specific pin configurations, and I can query the chips and say, hey, are you there? And it'll respond. And so I would like to be able to figure out how to make the nerves application take that burden off of the user for knowing which chip and what pins and everything like that. But before then, the exciting part. All right. Well, let me ask what you want to do. Do you want me to show how to start from scratch with a Nerves app and just pull these packages in and just go? That takes about 10 minutes. Or I've got them running on Nerves firmware right now, and we can just kind of talk to some chips and do some stuff. Ben, why are you laughing?
You're excited.
Because I'm excited.
I think it is never a bad thing to show what it's like to start with Nerves.
Okay.
Particularly.
Yeah, I can totally do that. I'm going to bring up one more terminal window because you can't ever have enough. All right. This is where it gets exciting. I'm going to do, oh yeah, you need a font bump, probably, right?
Yep.
How's that? Good? Yeah. Keep going.
Whoa, Tim.
All right, too much. Oh, why'd you resize the window? All right. Okay. So you have to have Nerves already. I'm not going to go through that part. But once you have Nerves installed, and there's a really good guide for that, and Greg worked a lot on that as well. So kind of sad he's not here. But yeah, it installed some stuff. This is kind of like Phoenix.new or any of the new mixed new kind of projects. So I'll go into the meetup. And everything probably looks pretty familiar for an Elixir application. There's like lots of stuff. Now, one of the things that's a little different, if you're not used to doing anything in Nerves, is that there's like dependency targets now. So if you're running on a host computer, your dependencies will be here. And then all of your targets could be like the Raspberry Pi, the 0, the 2, the 3, BugleBone Black, Linkit, all the different targets that are supported in Nerves. But for the most part, you want to kind of hang out in the target area for things that are specific to the Raspberry Pi or like a tiny computer. What'd you say?
Stay on target.
Yeah, stay on target. So I'm going to pull in subg RF spy, and I'm going to pull it from GitHub. Is that the right thing?
Yes.
No. This is the part that's going to take 10 minutes, is just remembering how this works. Okay, we'll try this. We'll see what happens. And I think I made a special branch for the meetup because it was broken on master. Shh, don't tell. Yes, Elixir Meetup. Uh-oh, we're going off the edge of the screen. Oh, that was close. I wasn't sure what was going to happen. All right, and we'll just go ahead and pull in the other one as well. So RFM 69 is the package name.
Can I ask another question?
Yes. That's a pretty good simplified explanation of Nerves. It's the thing that takes an Elixir application and a bunch of other stuff to make the operating system work, and then puts your application on top of it and boots right into it. Okay. And so this application is going to basically be the only thing that runs on the Raspberry Pi once it's up and running. Yeah.
So it is the thing that sets up the embedded Linux operating system and makes it small using build root, and it boots your Elixir application running in that unified Linux container.
Yeah, that's pretty good. It replaces the regular init scripts that start all the other services and like DHCP and all that stuff, your time on your clock being set and all that. It replaces all of that with just something called ERL init. So it just boots up the Erlang beam and your application on top of it. So you take control over everything. Literally, you have to bring up every part of the system that you care about hardware-wise. There's no like cron, so you're not like scheduling stuff. You have to build that in your app. It gives you full control over the system, which is nice because if you're building an embedded thing, you kind of want that. So when you're building with nerves, you need to specify a mixed target. Otherwise, it, I believe, defaults to host. So I want to build for the RPi 0. These are all. Yeah, sure. So I'm going to build for the RPi 0, and I need to get my deps. All pretty standard stuff. Okay. And then something a little different than a normal Elixir project is you build the firmware. And so hopefully I already have all the things that I need. Okay, the font's too big. So what it's doing right now is it's building a firmware file. So by the end of this, there will be this FW file that can be basically flashed right to an SD card and then booted right into. So we're going to do that. This doesn't have any like wireless, well, it has the wireless configured, but it doesn't have any like networking that it brings up. There's no like link local or anything. There's some other stuff that makes that really easy, but this is, I'm trying to get like a really quick example. So I'm going to pull a Frank here and just pull the chip because I can do that. People are like pretty hesitant to like mess around with their hardware. And I watched Frank when he was doing the nerves training, and he was just like ripping SD cards out and like unplugging stuff. And I'm like, okay, well, if Frank does it, that's probably not a good reason for anybody to ever do anything because somebody else did it. But that's my.
It's more impulsive than I expected. Like when we were on Frank's, he's like, deploy the thing.
So the story behind that, I need an SD card, micro to regular sized, by the way. There's one downstairs in my bag and the little container that has the insulin pump, but I forgot to bring that up. So yeah, I'll tell the story while James is doing that. We're on this guy, his name is Garth. He's really, it was great to meet everybody at ElixirConf this year, but he offered to take us out on his boat, which is an understatement of what it was that we were riding on. It was this beautiful yacht that he had. And we're out in the harbor, and we're driving around on this yacht, and he runs the navigation software on that they built with nerves. And so while we're on this trip, he was going to, while he's in the harbor, like upgrade the firmware on it from his phone.
No, this is worse than deploying on a Friday night. Like, no.
Well, it wasn't that bad. So we got back. We waited until we got back into the till we were docked and everything. And he was really just messing with Frank. He had it up on his phone, and there was a button that said firmware update available, and it was like green and like please press me. And he's like, I don't know, should I press it? And Frank's right beside him going, push it, push it. And we got a picture of it in the dark almost, where Frank is just like hovering over him, trying to push the button, like will him to push the button. It was such an exciting trip.
Next level. You're like, I'm going to jump off this boat. That's okay.
Yeah. Oh man, we can talk about that later. that was an excellent conference. It was fun the whole way. I hope it's in here. Thanks. Cool. All right, so while I was yakking and telling stories and stuff, it finished building a firmware. That's good. So once you have a firmware that you want to use, you just call mixedfirmware.burn. And it auto-detects an SD card if you've got one in there. So you tell it, yes, please, and I'm just going to like pull that over. It wants to know my password. All right, so it's burning the firmware. It's only 27 megs, pretty nice. So there's an operating system and a nerves application on here ready to go. And I don't know which one, which of the screen sessions this one was, but we'll find out.
Good thing is I ran down here and
Oh, this one. All right. So that one is, yeah, 14.1113. 111, how many ones? I don't know. All right. So what it's doing on the first boot is it found that the application partition wasn't formatted. The application partition is a special partition. You can write configuration and things like that too. So on the first boot, it'll format it, but on every subsequent one, even on an upgrade, it won't overwrite that. And so you can keep stuff there that's persistent across upgrades and things like that. But I'm in an IEX shell. I have both the RFM 69 module available and also the subg RF spy, because I brought both those dependencies in. You'll notice they look pretty similar. They both have set base frequency and a number of things. So they're basically adhering to the same protocol as each other, or they have the same functions, and that's important because I need to be able to kind of treat them interchangeably. And I will just grab some really fancy stuff from another screen here really quick. All right, so I'm going to tell it, use the UART and not the SPY version of this thing. And then I'm going to try to start a link with the serial. It's probably going to fail. Yes. So sometimes it returns OK, but nothing. It's supposed to return the string OK. We'll try it again here. It's almost always the second time that it works. I haven't figured out exactly what that is, if I'm just not waiting long enough for reset or what. But no, it's like, you're in a meetup, so I'm not going to work at all. I think that's what it's decided. All right, I'm going to try this. I don't have a reset connection on this one, so I'm just going to pull it and put it back in and see what happens. What could go wrong? OK, it started that time. Great, wonderful. So I'm going to set the frequency on this thing to, sure, 916.5. So that's 916.5 megahertz. So let's like talk to it. That seems like kind of a cool thing to do. So I'm just going to say read for 60 seconds. And it's listening on this same base frequency as this one. So when I send a message, it gets it. This is not, there's no data whitening, there's no like 4x6 encoding. This is just straight, I'm going to send this essentially Morse code across to you and you're going to pick it up. That's a really good signal because they're like right next to each other. These two, if you notice, didn't do anything. They're not actually listening on the same frequency. So if I were to tell this chip to set its base frequency also to 916.5, and then I told it to listen, it uses the same basic contract. So I'll do that, and I'll do that, and then, yeah. That's pretty bad for some reason. I don't really know why that's happening, but. All right, so you can kind of see how like setting the same frequency, you get the same packet structure and like modulation and everything. You can communicate across these chips, and they can get pretty far apart. But if you've got them on different base frequencies, obviously they're not going to talk to each other. So this one has been waiting for me to give it the special secret. It's just been sitting here in this loop waiting for something to happen. So when I send it something, it's not at all interested in thing. But if I send it the secret, hey, we won. So it actually received the right thing, the thing it was waiting to receive, and then it ended. So these are, like, I guess it's kind of interesting to me, at least, that on the right side, we're talking to these RFM69HCW chips. On the left side, we're talking to these CC1110 chips. They're like different manufacturers, different specs. One of them requires special firmware. The other one just kind of is like almost infinitely configurable. And yet they're talking to each other just like they've been friends their whole lives. So that's kind of where I'm at. I've got it all working well enough. Some of the timeout logic is a little bit flawed. Some of the underlying pieces that I wish I understood better are just sort of like cargo culted in. For instance, if you want to see what the configuration of one of these things looks like, it looks like this. So this is the configuration for the RFM chip. This is a struct that has a 2 binary on it. And so if we go and look at the documentation really quick, this is a very special address, 0, but the rest of these things are just regular registers. and there's this thing called write burst on this chip. And so if you start at any one of these addresses, and you're in SPI mode and you're in SPI write mode, which is the special bit that's turned on the first byte that you send, then you can just keep writing bytes to this chip, and it'll just increment the register value and put whatever you send it to that one, like store it there. So you can write the entire registry with like one single command and a bunch of bytes. This FIFO queue is actually a little bit different. If you write to address 0, it'll just keep queuing up and put in a shift register and like keep shoving more bytes into the transmit queue, and eventually it'll transmit those. Similarly, with reads, it works the same way. You can read a burst, so you can start reading at like address 2 and just keep reading, and it'll keep giving you more register values. And if you start reading at 0, it'll give you whatever's in the FIFO that was ready to be received after it sent you that interrupt pin. So there's all kinds of really interesting things going on in the hardware underneath this that took a while to figure out. But once you've kind of figured it out and it starts working, it's like magic. All right, so where are we? I kind of thought it would be kind of fun to play a game. But I'm not very good at making games up. But what I thought would be kind of fun is if we keep the 2 chips on the left up here, and we decide on some kind of a secret, and then split up into 2 teams, and whoever figures out the secret first and sends it wins. I don't know, does that sound like fun? Or?
Yeah, is there clues?
I don't know, that's the problem, is I didn't come up with a good secret. I'm really bad at this. Yeah, I don't know. I mean, I thought it would be kind of fun just because you can hook into this thing via regular USB. It just shows up as a serial device on your computer. And you can do a screen session into it. And you're talking to the IEX session that's on the chip that's running. And you can do all kinds of really neat stuff with these things just at runtime, like not even writing the code in advance, just playing with it. So I don't know, that's an idea. I also have a really hard for me OTP question. Like the design of this thing is really difficult to me. I want to be able to make the experience for users of this thing that plug one of the commercial versions of these chips onto it, not have to think about which chip do I have and how's it configured. I just want them to be able to plug the thing in, and when they boot up the firmware, it's the same firmware as everybody else has, but it knows their chip and it detects it and everything just works. And so what I've struggled with most is the supervision tree around that. Like I can query each chip individually. I can go through and like sort of cycle through each possible combination of pins and things and figure out what chip I'm talking to. But the thing I've struggled with the most is like, okay, now I have this, essentially this PID of the chip that I want to talk to. What do I do with it? How do I either put that in a supervision tree or shut it down and use the configuration I know works and pass it into a supervision tree? But I'm kind of stuck there. I mean, I'm a little bit out of my depths as far as OTP design goes, and honestly all the books are like, here's how to build chat servers and use like the Elixir process registry for the chat server name, and I'm like, well that's great, but I only really need one of these things. It just happens to be a different chip potentially every time.
Is the
So.
kind of the question how to add something to a supervision tree after initialization?
No, let me see if I mean, it might be. I guess maybe I don't really know the question that I'm asking. And that's part of why I've struggled with this for a few weeks now. Let's see if I have it. Oh, merge conflict. That's the best. Let's just see what it says. I don't really remember where I left off. I'm okay throwing everything away, basically. But I'm off screen, I know. I'm just... Man, this is too much like regular work.
I see like 0 Webpack, so...
Yeah, I've somehow avoided Webpack so far. So I'll consider that a victory. Maybe I have it up, maybe I pushed it up. I don't know. The question, I have many questions, like where does this live, and when I find out where it lives, what then? I bet it's all locally in the other project. Here we go.
If we get into the OTP question stuff, we'll probably
Okay, let's not even look at this. I'm not sure it's useful. So I've got it basically starting the supervisor, and then after it is fully initted and everything, starting the children. But really, it seems like that's too late for me to do the chip detection. Like I just kind of threw this out on the internet, desperately asking for help, and Amos came up with this idea for me to try, which is separate out the starting of the supervision tree for that chip from the thing that detects, and run the thing that detects, and then basically kick off the supervision tree based off of which chip I've already detected. I really basically lose nothing with that approach. The only thing that it would potentially lose is that if I unplugged one chip and put another one in while it was still running, it wouldn't be able to adapt to that. But honestly, that's a use case that is not really all that valuable to me. That's more like parlor tricks of like, here, look what I can do. That's not something somebody's going to do in real life.
I don't know if that's true. I think there might be a way you could have that.
Okay, like if the supervisor died, then have the thing be, okay.
How tricky is it to add something? How tricky is it? Like, I guess you could bring up the regular supervision tree, then check for the chip, but you're saying it's too late? Too late? Why is it too late?
Well, I've just been having some difficulty. So it's not necessarily too late, but I've been having difficulty with, once I'm in that whole supervisor and init part of it, talking to chips means opening up serial PIDs to talk to them and then shutting them back down. And there's just a lot of things going on. And everything I'm reading says don't do this really complicated stuff in supervisors. Like don't, like try to keep your supervisors relatively slim and like not prone to crashing and everything. And so it just kind of feels like there's a smell there, I guess is really what I'm trying to say. I'm going to turn on the audience camera. Is anybody queasy about being on a stream? No? Okay, good.
So, do you want me to?
Yeah, I want whatever you got.
So, high level, what I think Amos is saying, and I think I agree with him, is your main application starts, right? You know, it has a start function. It kicks off the whole application and TP structure. One of the things that needs to start is something like a chip detector. And it could be supervised.
Oh man, if there were dip switches, there could be a dip detector too.
Yeah, right.
Yeah, I'm in. The puns could go for years. All right, so there's a chip detector.
So there's a chip detector, right? And the chip detector, all it does is it starts up, and however you're detecting chips now, it does that, right? Once it detects a chip, you know, chip detected. That happens, it fires off a message to that chip. Either it calls, you could add another layer, or you could say, once that chip's detected, it knows what module corresponds to that chip, right?
Okay.
And that calls that module's supervisor. So let's say chip supervisor. It's called chip A. Supervisor. You know, dot start. Now, the chip detector is still a process running. It's still looking for chips, right? But now chip supervisor A has started the chip that was detected supervision tree, right? Now, what that means is that depending on how you start it, if it's linked, then it's linked to the chip detector. So if the chip detector crashes, your chip's going to crash. that might not be desirable. So what you might want to do is actually have a chip starter process, right? It's separate from the chip A supervisor, and it just knows how to start chips. This detects chips, this starts them.
And the likelihood of this thing taking down the whole supervision tree is pretty low.
Yeah.
Okay.
So can you start a supervisor without it starting its children? Is that what you're saying? You start chip A?
Start without link.
You start a chip A supervisor, chip B supervisor, chip Z supervisor, but none of them actually started up their children yet? Is that?
They would start their children when you call start on them, right? Like these
So
really
they
should
themselves
be.
are running.
These should really be maybe even applications, right? The thing I was saying is that whatever starts it, you know, is going to be linked to it, right? So because you started it, the process that starts this is linked to it.
Right.
So you might want to have a separate supervised process to start.
So I've only started them in that init, whatever that function is there but you can just define them and then just call them later?
So right now there's a couple ways to do this.
That's kind of neat.
I have a different pattern that I've been using, which isn't to say that it's right, but I'll.
Yeah, the dynamic supervision, yeah.
If you're using a simple one-for-one strategy.
Yes, then the supervisor knows how to start his children and they can dynamically start children. So really you're calling this supervisor start child function.
I'm gonna have to leave it to this.
So one of the things that I wanted to avoid was having the supervisor crash because of something that I did here. Partly because it makes it easy. As long as my application at the application level doesn't crash, then I can remotely apply a firmware upgrade. And I think this is sort of more vestigial than something that I need at this point, but I'm actually calling start link. I'm calling supervisor start link using just one-for-one as the supervision strategy, but then I turn around and start workers after it's up.
Oh.
Which is definitely not a pattern that I think is necessarily something I would do anywhere else, but this was specifically because my application was crashing and I wanted to understand what was going on, but still be able to remotely firmware upgrade. I think some of the other gadget init stuff and all the other things that have come along with nerves have solved this problem for me a little bit more. But this was my way of making sure that even if I had a bug, that it wouldn't take down an application and my whole thing with it.
So you, in start workers, you pass is this the PID for the supervisor?
Yeah.
Okay. That makes sense.
And server is I can't remember if it's an agent or a gen server that has some runtime configuration loaded from, I think, a JSON file. Something. It's loaded from a file. At one point, you could configure it via a web server, which I can't bring up because I don't have one of them running, but you could type in like pump serial numbers and Wi-Fi access point credentials and things like that in the web server, save it, it would load that configuration and then basically restart the whole thing.
This is an interesting way around simple one-for-one.
It wasn't intended to be simple one-for-one, right? Like the idea here isn't that it's supposed to be a dynamic supervision tree where things can be added and removed. It was, why are my supervised children dying and taking me down with them?
Yeah.
Yeah.
Yeah, because in a simple one-for-one, you just need the supervisor to understand the child spec so that it knows how to start it. Now, I think in Elixir 1.6, supposedly we're getting dynamic supervision, or a dynamic supervisor, which is its own supervisor type. That might solve this. So, you know, once you have this solved, maybe it's not worth putting a ton of effort into the implementation of it until 1.6 comes out. a message to the chip starter about which chip to start, and it tells that supervisor to start a child that's supervised by the starter, or it's linked to the starter, that's okay.
Yeah, I think I can go with that. I think I have enough knowledge of how this stuff works to be able to push on that a little bit.
If this stops and you plug in another chip, the chip detector is still running.
Yeah, that part isn't really not as important to me. Like, people are not going to be swapping these things out while they're running.
Except for return time.
Unless they're frank.
Or putting a keynote somewhere.
You're right. Yeah, no, I don't really need that. So to make things a little bit more complicated on myself, I think the design of this thing, there's another part of this that I don't really understand how to do. And that is, okay, so if I have one of these things running, right? If it's this one, if it's the RFM69 SPI, then the module that's, here's like a key for a legend for this wonderful picture that I've drawn. The like cylinder things are basically processes, right? So if I spin up a SPI process to talk to this chip, the RFM69 chip, then I have some functions that are outside of the process that know how to talk to this thing because it's registering by name. It's saying, I am the RFM69 SPI chip. I don't really need to have more than one of these running at a time, for what it's worth. But I communicate with it via, so like if I'm over in this area and I'm talking to RFM69 and I say read, then it knows, okay, this is the thing I need to ask. This is the gen server that I need to ask because it's been registered as that alias. There's like some state that I'm missing here because when you're up at the top, it could be either of those processes that's running. They could really register, I guess, under the same alias, but then it's just kind of like, I've got this weird state where like, I both need to know which family of chips that I'm talking to, but if I'm talking to this family of chips, I also need to know, am I talking via UART or am I talking via SPI? And I don't know, I think it's just like a case of missing state, but I don't really know where that state belongs.
Right. I was thinking maybe you could solve some of this with a registry where you register the process for the chip that you start up to a chip registry, but now that you're saying like, oh, I also need to know. It seems like if the process needs to know what kind of chip it's talking to, then you're missing a layer of abstraction.
Maybe it's in the chip supervisor. Maybe once I've detected it, because I know it's the sub-GR SPI UART, that just becomes some of the state that's owned within that supervisor. Does that make sense?
Well,
like it has to know how to restart the processes, right? So it's going to have like a child spec. So it's going to know that's the one.
Yeah, but the thing is that if you have other processes that have to communicate to chips, it should go through like a standardized API that doesn't care about what type of chip it is, right?
Yeah, I think that's where the disconnect is, right?
Yeah.
So like in my brain, I'm seeing, okay, it doesn't really matter as long as I have a PID and I send it the right message, everything should be fine. But these aren't sending messages to PID. These, like, it's calling this module's read function and it talks to a gen server. So there's like stuff outside of a process here. And it feels kind of weird to like wrap all of this in a process just so I can send it a message because there's literally no state outside of what's going on inside here already.
It might be the right thing to do though, but at the same time there is overhead, right? Like
well, you're single threading, like you're taking the communication with the chip that's already basically throttled here, and you're doing it again. So I don't know that there's any downside to that because it's like you can't communicate to more than one of these things at a time anyway. Yeah.
Just a thought, I don't know if it fits, but the fact that you have the same API for these things that just is differentiated based on like the kind of chip it's talking to screams protocol to me. So I don't know if that really fits, but like if you have some differentiating state for each type of chip, that's something you could have a protocol switch on, so it would be like polymorphic behavior. And,
I see.
yeah.
So we were talking about it in terms of behaviors.
I think
You had introduced the idea of a protocol, but there's no shared behavior from this read. Sorry, there's no shared implementation detail from this read to that read.
But that's the point, is that the API, the protocol is the same, but the implementation is different, so it's polymorphism, right?
I get it, but there's no like default implementation of that, right? Like there's no,
Well, the default,
I'm not inheriting any behavior between either of these, other than just the function declaration.
you just want for it to know, like, in order to be a chip, I have to implement this protocol.
But I mean, I guess this is like where I'm falling down in my transition from OO into the Elixir side. I don't want any specific behavior to be shared between these because read looks very different between these.
It's more like an interface. What you're doing with the protocol is saying to the outside world, this is how you can invoke the behavior that I'm providing here.
But I guess I thought that was what a behavior was for. I thought the behavior was like, this is the definition of functions that have to be done.
Brings implementation in, right?
Is that right? So am I thinking about it backwards?
I think so.
I think you're thinking of two different things.
Yeah.
Well, so my understanding is one of them is essentially like defining an interface, and the other one is essentially potentially defining an interface and some implementation details that can be essentially inherited. But
So you coded Ruby,
yeah,
right? Did you code, you didn't code Java?
yeah,
You did?
Hmm?
Because they've got interfaces in Java, right?
Yeah. So what is the analog in Elixir for an interface?
So you've got
Okay.
an interface,
Behaviors makes sense.
and there's.
Okay, yeah, I got those backwards. So the reason that we backed away from protocols is that these are two low-level packages that share nothing with each other. So where would I introduce another?
That list up there where you say read, write, set frequency.
Right, but where would that be a separate hex package that they both depend on as a dependency,
It could be, or,
and only declares like this one protocol?
All those are all hex packages.
yes.
Yeah, they're separate hex packages that share nothing. Like the only thing that knows about both of these together is the thing above it. They don't.
I think it is maybe a separate hex package, though that seems like way overkill.
That's the beauty of protocols, though, is they don't have to be bundled into the things they're implementing. You can actually implement a protocol from the outside. So
Okay.
if you've ever heard
Or
of
it's
the
not like interfaces. Interfaces in Java, you do need to point to it, right? But in Elixir, you don't.
right, you may have heard it called the expression problem. And this is a solution to the expression problem in that you can have these external libraries that have data structures that don't know anything about your protocols that are in your application level code, and you can actually implement protocols for the external data structures directly in your application code without touching those libraries.
So are you saying that at this level it would declare that they adhere to whatever protocol that I'm saying?
In your box that's labeled pumpcom at the top,
Yeah.
you could define your protocol there, and you would call it, I don't know, chip
Okay.
protocol. And the protocol would say that this protocol declares three functions: read, write, and set frequency. And the trick is that protocols do their polymorphic behavior based on their first argument. So when you implement the protocol, you don't have to do it inside of this package here, but you have to have something that say, I'm implementing this protocol for this data type. So if these hex packages declare like structs that represent the data, that's what you would use for your first argument in your impl.
Okay.
So you'd have a def protocol that declares those three functions, and then you'd have two implementations of that protocol, one for the top box and one for the bottom box, presuming that those each have their own structs that you could kind of like switch on.
Okay. That makes sense. I'm interested in that because we basically fell down at the point where it was like, well, wait, we have to have another hex package that these things would have to work with. But
if somebody wanted to use your individual hex package, they could,
They ought to be able to be blissfully unaware of the fact that there's another one out here that just happens to look the same as everything else. Like that shouldn't matter to them.
Isn't there some kind of spec or something that you tell it implements a protocol? When you tell the function that it's an implementer?
There's usually a tag an implementation with definitely. Yeah. But you do that in your application code, right? Like
In those boxes.
yeah, so your
That
protocol.
would be okay even though they didn't know about the protocol?
Yeah, because your def impls would go over in your application level code in this case, or in some external package that sits above those two things.
So protocols are done at compile time too, so you want to consolidate them with compile time. That's just a minor detail when you do your production config. The interesting thing about nerves is I think you would always do that.
Yeah, right.
So here's something that just occurs to me. In object-oriented, we have all this nice UML stuff that we only use 10% of.
Or UML libraries in Erlang and OTP.
But I'm just wondering, how do you express all these crazy functional ideas? Everything's a function, so.
Hey, look, if it has state, it's a cylinder like a database.
Yeah.
Okay, that's what I went with.
This needs a little bit of expository.
So usually in Elixir it ends up being process diagrams because that's the thing that you care about representing.
Yeah.
I don't know if there was.
There is libraries for working with that, and then standard library too for generating those. If you do a trace, it'll actually generate that diagram for you.
Which diagram?
The process diagram.
Yeah, I didn't know
like
that.
in what format?
Dot format.
You can generate a trace of your.
Yeah, or you can just fire up the observer and look at it live.
Who's completely lost right now, by the way? Okay.
Sorry.
Can I be a little bit lost?
Yeah, that's good. I think I'm mostly lost. Like I'm more than 50% lost.
Because that means you're like on the right track. Yeah, that's how I feel at functional, by the way. Every time I go to Cincy functional, I'm like, I'm almost lost, but I understood some of those words.
You know what? Actually, I was feeling very insecure about Cincy functional, and I brought that back to this meeting a few months ago, right? Yeah. And I think I'm just the opposite now. I'm feeling like Elixir is so amazingly cool because you can do lots and lots of stuff without even knowing that. and
I'm just going to slide this over, hopefully, so if you're talking, it'll pick you up.
I watched of this lady that is developing a package called Witchcraft.
Yeah.
Have you ever heard that? Yeah. So it's actually like trying to bring back all of those fancy words from other functional languages into data structures that we can use that stuff in Elixir. And I watched the whole thing saying, this is so super cool. Why on earth would I use it? It just kind of.
I haven't felt like I needed it.
I don't know. I'm still wondering what we're missing. We're getting so much done.
Yeah. So, I mean, there's a common saying that Erlang is a productive functional language, right? Like, it focuses on productivity before it focuses on functional purity, right? That makes some people feel differently than others.
That's an interesting way to put that.
Well, I'm willing to be. I'm willing to feel insecure and productive at the same time.
Yeah. Well, it's like Jason's talk on typing with Dialyzer, right? Like they had to come up with the term success typing, right? Because Erlang is not statically typed, and so they come up with Dialyzer that was showing all of these errors in the code where these types theoretically were not wired up correctly, the code wasn't wired up correctly. But you can't say the code is incorrect because it's been running in production for 50 years. Right? Yeah. So just because something is
So I thought I would point out while you're writing that up on the wall, on the board. This is the first project that from scratch I did type specking on.
Good job.
And docs and stuff. That was fun. It's like learning another syntax for Elixir. Like it's like learning a whole other Elixir on top of Elixir, it felt like.
It also makes you think more about your functions, for sure.
Yeah. So I had some help on PumpCom with documentation and everything, and that was really cool. And it was an example of me thinking, hey, this is all right, and then somebody pointing out literally every single problem that I had, like these are not consistently passed to each other, and this isn't called ever, and you should get rid of this, and like that. Yeah, yeah.
Dialyzer plus the person who did it.
Plus the person who did it, yes.
So if you put that stuff in and you don't run dialyzer, does it still help you? Does the compiler use it in any way?
So where it's actually used that I think is useful is in the documentation, right? So Hex Docs. Let's go to this one.
Yeah, the compiler doesn't use dialyzer. You have to treat dialyzer somewhat as your compiler.
So if I go into like set base, well, I guess I need one that has like a struct that's being, here we go. So this configuration struct has all kinds of stuff on it. And if you go into it and you look at the documentation for it, you can actually see where it will link you to the type for the configuration. I think. I thought I did that. Yeah. There we go. And so I'm in the configuration, which isn't all that helpful. But when you actually like define a struct or some other thing, or you reference another module, it'll help a little bit with that, I think, right? Jason, you ready to help me understand the way?
I might not have all the syntactic details right here, but just to get the idea across, you'd have a protocol that represents the essence of being a chip in your universe.
Mm-hmm.
So that is these three functions. I don't know what all arguments these things would need to take.
New Zealand is following us.
That's funny.
So hello from Auckland.
Hi, New Zealand.
So you would have your function declarations, and I don't know what all arguments they would need to take, but you can fill that in. But the crucial part is this first argument here.
Okay.
That's your switch for your polymorphic behavior here. So these don't have any implementations. You define your implementation separately for each type of thing you want to implement the protocol for.
So is chip a module? Or is chip like a PID? What is?
In here,
Yeah.
this word chip is just the name. Of the protocol.
Sorry, in the function declaration.
That is like yet to be determined. That's
That's your data
determined
type.
by your implementation. So it's
Okay.
kind of like a placeholder.
All right.
So that would be like a struct. Like that might be a sub. Am I wrong in that might be like the sub RF spy struct when the sub RF spy is implementing the chip protocol?
Right. So it's like your object reference to think of it in OO terms. So in here it's just the name because all we're doing is declaring the function and the parameters it has. So this is just declaration of what the protocol is. These names in here don't mean anything yet. It's only when you define your implementation of that protocol for a particular data type.
Okay.
So that's what we're doing here. We're saying we're implementing the chip protocol for this specific data type here. That means in here you're actually defining the functions now, knowing that this chip argument here is actually going to be this data type that you're implementing the protocol for. So you would implement your read, write, and set frequency function, and the first argument in your implementation here would be an instance of this data type.
Okay.
Okay, and so what that allows you to do is then, like when you want to actually use this thing, you just call the function on the protocol with the right type of argument. Like so, let's say you initialize one of these guys somehow. So you have a handle. That's your device or your struct or whatever your library gives you. It's an instance of one of these. And then you just call chip.read with that thing. And what the protocol does is, so you're calling a function on a protocol, and it looks at the type of that first argument that you send it, and it looks for an implementation for that type. And then it'll match on this data type here and end up calling this version of the function.
Okay.
Yeah, so in essence, it's like pattern matching at compile time, right?
Where is a good example of this in practice?
I can send you one that you have access to.
Yeah? Okay, just me, though?
Yeah.
Okay.
Does Elixir School have a section on protocols?
It does. I believe it does. Elixir School is fantastic, by the way, and if anybody from there is listening, thank you so much.
So this is exactly like the object-oriented analog. So here, you're initializing your object reference, however you would do that, I don't know. And just the only difference is like the syntax. Instead of calling that thing .read, you're calling the protocol name .read with that as its first argument.
Okay.
But it's storing the same polymorphic type of thing that you would have in the other language.
But it's a little bit better because the dependency management is.
Yeah, so you can construct this all from the outside. Like in our code base, we're using protocol and implementing it for a third-party library that we actually don't have any control over, but we're able to implement that protocol from the outside anyway.
So you're using this kind of like an adapter kind of a pattern?
Yeah.
Of like, oh, that's pretty neat.
Yeah, it's exactly what, yeah,
I like this.
the adapter pattern. Yep. And so the example that you have access to that nobody else does, that
Secrets.
isn't a Gaslight employee, it is the adapter pattern, like it's an API adapter.
Okay. I mean, in this case, I own both sides of it, so I could make the RFM 69 and the sub-GRF spec look however I want, and right now they look pretty much exactly the same. But if they didn't, I could make them adapt to a protocol that's different, right? That's pretty neat. That seems pretty powerful. So I've read through the protocols and the behaviors parts of like the programming Elixir book and stuff a number of times and just did not get it. Oh, okay. Yeah.
So for any of us that are gluttons for punishment, this great link somebody in Word sent out on the definitions of all the weird functional concepts, and it's a really good overview of all the things that we don't need to know.
Yeah. Well, and some of them just you don't end up doing because of the limitations of the language.
Yeah.
But I don't miss it. Like
The
currying or partial application.
Those
That's
are the
what-
same thing. Currying, auto currying, and partial application.
Partial
Maybe I
application
should read that again.
you don't necessarily have to have currying to do partial application, I think, but it makes partial application really nice.
So an example within Elixir of protocols would be inspect, right? Is that?
Yeah.
Okay, I think that's the book examples usually of how do I inspect something? Well, here's how you can inspect a string versus here's how you would inspect something else. Okay.
Yeah, and if you think about it, you're literally calling inspect with the data type, and then it's pattern matching on an inspect method that takes the first argument of that data type, right?
Okay, so
Also, you're inspecting a tuple.
Yeah, so that's an implementation of that protocol for the tuple type. So you can create implementations of protocols for lots of different types. Like it doesn't have to be like a struct that you're making. As you can see there, you can implement your protocol for built-in types, but it's most powerful when combined with structs, because you have structs that represent different types in your code, and you can differentiate between those different kinds of structs.
Yeah. Yeah, and pattern matching and structs, there's a lot of functions around like struct equality and stuff like that that is really nice. You can take advantage of. Also, structs use maps under the cover, and maps just happen to be like the fastest data structure to work with.
Really?
Yeah. It's a weird case where it's probably the most recently implemented data structure, so maybe that's why it got so much performance tuning, but yeah. So a lot of things under the hood are using maps.
The tuples are secretly maps?
I don't know. I suspect that tuples are actually
I would think tuples would be.
in fact, yes.
Would they? I mean, they don't do anything.
Well, it depends on what you're trying to do with them, of course. So, records in Erlang are implemented using tuples because they long predated maps' existence in Erlang. And so they implemented records, which are like structs in Elixir, but they're implemented with tuples instead. But maps are, you look up fields in a map by, getting the hash code of the key, whereas if it's in a tuple, you have to traverse the elements to find the one in the matching position. So, Also, Elixir used to have records.
Yes, until maps came along.
That was 1.2
Used to have what?
records.
Right, records. I think one of the old versions of programming Elixir referenced records, right?
Better than the name struct. I wish they
Yes,
would.
I just,
But I understand they chose the right name in the first place, but then they had to get rid of it because they were completely useless.
Naming things is hard.
I think, yeah, Jose talks about this a lot. Like, if you talk, like, designing language is hard for lots of those reasons. Because you have to live with your decisions for a very long time.
All right, I don't really know where to go from here. I would like to write some code, but maybe not right here up in front, in front of everybody.
Do mock programming. Or as I like to call it, everyone yells at you.
I wondered how that really worked in practice. Everyone yells at you programming just doesn't have the same ring as mob programming. So I thought maybe it would be kind of fun a little bit, just for a few minutes, to just play with the hardware and send messages and stuff. Anybody interested in that? Getting away from some of the more deep technical stuff, I think for a few minutes would be good. So I'm gonna do the risky thing and just like rip all the scary, right? Just unplugging everything all at once.
It's like 1,000 processes suddenly.
Right out, and then we're silent. Who wants this one?
I got a computer.
You got a computer, you should plug that one in. This is great, this is so much fun. I get to hand out, it's like handing out candy at Halloween. If the candy looked, well, to the untrained eye, looked like a bomb. And I guess technically this would be more like the remote detonator, because it's got, okay, we're on the internet. I keep forgetting we're on the internet. Who wants this one? Anybody? I'll plug this into you, yeah. Did you say eh? Anybody else want one? All right. I'm just going to plug this in, and rather than maybe playing games and stuff, you just send me a message. So the 2 chips that you have, you need this gist for. So I'm just going to toss this into the Cincy Tech Slack. Alex, do you have that? Okay, never mind. I will send it to you privately via secret message service.
If 2 chips transmit on the same frequency, what does the relay hear?
I don't know. You mean at the same time? So I have implemented on the higher level side of it listening. So it listens for silence for 5 seconds before it's willing to transmit. So if it starts getting packets, it'll say, okay, wait, something's going on, because there's other things that are going on that frequency. But if it doesn't detect anything, then it'll transmit. And then it kind of takes the reins, because everything else should be polite and listening. But if 2 try to transmit at exactly the same time and it happens, within what I'm doing, every message at the beginning of the packet has the address of the intended recipient. And so if it gets the wrong intended recipient, or it gets a response to a packet that it sent expecting to have this address in it, and it gets a different one, it kind of just freaks out. Everything crashes, and we let it crash, and then it just kind of comes back up and everything's fine again. As far as what we're doing, there's no politeness at all. So I don't know what happens if we transmit at the same time, but it's probably not a good thing. All right, Alex, I sent you the link. And James, where are you? No, you can just run it in IEX. I'll show you how to do that really quick. Yeah. All right, so you should have, I'll just kill all of these. All right. You should have, if you're at the terminal, you should be able to type in screen and then /dev tty USB, and you should have a USB modem pop up on there. It'll have some random number. It could be 1413. You know, it just depends. But on a Mac, they're all pretty consistent. Do you see anything like that? Yeah. Wait, which one? So, okay. It should be plugged into the OTG port already, so you should be okay with that part of it. Is it working for you or not working? If it's not working, it's probably my fault. Okay, that's exactly where you want to be. So you're in the console of the running Nerves application right now. This is going to take me like 4 attempts again, I bet. Just kidding, it worked the first time. All right, so I'm listening on base frequency 916.5. You guys are as well. I'm going to, I guess, just make a loop where I listen and spit out whatever it is that I receive. Not yet. Nope. But soon. Okay. Send me some stuff. Well, send me one thing and it'll end, but then I'll have to go back and change the code. Nil.clear buffers. That's scary.
When I call it set base frequency.
Which, maybe I sent you the wrong link. Did you have a big configuration block?
Oh, you sent me a link?
Yeah.
All the instruction things.
Hey, I'm just like writing code in the shell here.
Yeah, that one. Go to that gist right there.
Yeah, that one.
Very exciting. Yes.
Oh, wow.
Paste all that stuff. That's the giant configuration block that says pretend like you're an insulin pump.
No.
I mean, you could type that all by hand, artisanally.
Actually,
That'd be fine.
I'm wondering now, like, if I could. No.
Good times. Okay, so you have available to you a write function and a write and read function. The write function, which should be the simpler one, is actually the more complicated one, and that's my bad. But let's go look at it really quick. All right. So write takes in a binary. So usually you can just type in a string here, right? But it has to be null terminated. So you can do a string and then concatenate a null byte on the end of 0, right, as a binary. So if I give you like an example. Yeah, that's fine. But it has to, I mean, it's like a binary concatenation operator deal. You know what I'm talking about? Let me bring up another. So the trick is that it takes in all these different things, but really you just want to give me the binary that you want to send, null terminated, And then the number of times you want it to repeat, which is going to be 1 for this, for tonight. Repetition delay of 0 is fine because there's no repetition. And then a timeout value. So those are all the required things. So you can basically say, here's the binary that you want, 1, 0, 1000. And that should be fine. Hey, there you go. So James, I'm assuming that was you. See, now we've turned it into a race.
Sorry. He's just gonna win.
But I do like this though, because you do have to learn something about binaries.
So James, why don't you read now?
Yeah.
So the way you do that is rfm69.read and then a timeout, so do 60,000. And it should just sit there.
Reading.
All right, so I'm going to write you a message. And Alex, if you're kind of stuck, this is something to watch, except you'll be using RFM69 module. So I'm going to send it one time with no delay, and I'll put 6 seconds on here. It's almost immediate every time. But
Yep.
Did you get something?
Yes, I do.
Cool.
Ooh, what is the RSSI?
RSSI is the signal strength. The lower the, well,
The lower the better, yeah.
the closer to 0 that the negative number is, the better.
I should know this because the phone actually has the same exact property, and I suspect that the cell signal is just a different type of packet radio. Right?
I don't really understand any of that stuff.
Yeah.
I know a lot about these little radios, but I know very little about the hardware underneath. So, send me another message. I'm ready for more messages.
And it's sending packets across. So,
Yeah, so the RSSI, typically for what I'm trying to do, like practically speaking, once you get around -85, it stops really being reliable. 60 is usually pretty good. So when we're like literally right next to each other, that -20 is pretty, I haven't seen that before in actual usage with these pumps, because the pumps aren't tuned to a particular frequency very well. They just kind of spray across the potential band that they're talking on, and they don't have a lot of range. Did you send me? Did you send me a what up? Nice. All right, James, send me one. See if the loop's working, if the tail recursion is still working. He's going to try to crash it. I can tell you're trying to put the system to the test. How long are you making this thing?
While we have a pause,
Yeah?
can you explain to those of me that were here late
Sure.
what you're doing?
Yeah, absolutely. So what they're playing with right now is this particular chip. It's called the RFM69 HCW. And it's a pretty versatile chip. It doesn't require you to burn a firmware to it to be able to do any number of things. And so there's a configuration that you set on its registers. You basically write to the registers and commit those things. And then it has a FIFO queue that you can write bytes into. And it will turn that into whatever the configuration. So if you're doing like packet-based send that's on-off keying, then it will send it, it'll transmit over its antenna the way that you've configured it at runtime. And so where I have these other chips, the ones that are up here, and you can come take a look at them if you want, they're a Texas Instrument chip, but they require a special firmware to be burned to them to work the way that they do, where the other ones is all runtime configuration. So I've been playing around and learning about the RFM69 HCW chips more. There's a breakout here. This is a SparkFun version of it, but there's also an Adafruit one. And they're like 10 or 15 bucks to do this.
You're sending data over radio waves.
Yeah, there's no wireless, there's no Wi-Fi or networking.
How's it getting to James's machine?
So he's got one of the chips over on his, and Alex has one on hers. Yeah, so those, even though these are Raspberry Pi Zero Ws, they have no networking started up right now. All they have is a serial connection. And so there's no, it's not like, there's no like sneaky Wi-Fi happening behind the scenes. This is all over 900 megahertz.
But there's a definite range.
There's a range, yeah. I think it's probably the length of the building practically for this, but you could put more.
CC issues or anything?
No, these are in the unlicensed band, and they operate with low enough power that you don't have to worry about that too much. If you were going to build a commercial product, you probably would have to go through some more rigorous stuff, but
This is the future of walkie-talkie.
it could be. So ham radio enthusiasts are into packet radio a lot. And so there's actually, if you go to the Elixir Slack, there's actually a ham radio channel in the Elixir Slack for people who are trying to use it for doing kind of stuff like this, although the ham bands are different than the unlicensed stuff that we're using. This is like baby monitor and insulin pump range. I forget there's a name for it, but it's like industrial, scientific, medical.
And you would use it for something that sensitive, like your pumps?
I mean, yeah, so the insulin pump that I've got right here uses 916.5 almost exactly on the dot and uses the same modulation that we're using. In fact, we're sending messages like RM-RF, and the pump's probably like, okay, I'll delete all my files, sure. Who knows? We'll see. But no, like yeah, it's pretty cool that all this stuff is just off the shelf and you can buy it. And
To respawn the shell if you get.
it's delete star or truncate students, I think it's one of those like SQL students. You're cracking me up, James. Yeah, SQL injection over the IEX. This is fun. I like this. So I've been sitting around in my basement soldering all of these little prototypes together because I wanted to back up in case I fried one and released the blue smoke. And I thought it would be kind of fun to bring them all in and we could have fun with them here. So this is the only chip that I'm not running right now. It's actually the SPI version of the CC1110. And it would run too, but I just didn't feel like cooking it up. 4 Raspberry Pi Zeros is enough.
So it's also kind of a broadcast, right? So whoever sends it,
Yeah.
people are picking it up.
If everybody was listening on the same frequency, and that's one of the things I demoed at the beginning, although I don't think I got multiple receive. Did I? Did I do all of them on the same frequency? So if you can set like 3 receivers on the same frequency listening and one's transmitting and they can all hear yeah. So you'd have to figure out like the negotiation of when to send and when to receive. But for the most part, yeah, you could have like a one send everybody receive kind of a approach.
What might be really cool to try to do?
You're cracking me up. System alt. I think it's, I can't type into it. That's not going to work.
I didn't know terminate one of them, hoping.
I think it's nerves.runtime.halt or something like that. I can't remember off the top of my head.
Some not a whole lot of it, so that's nerve, Elixir standard library.
Oh, okay.
That's actually how you exit the shell, other than Control-C, Control-C. That actually gracefully brings down the node.
I'm not about gracefully bringing down nodes. I just unplug stuff. Yeah.
What might be cool to try to do is if you could implement a networking layer over the 2 packets and actually do distribution.
I see.
Yeah.
Maybe.
Speak the distribution protocol between 2 NERSC devices, and you'd have like a distributed cluster.
So the RFM chip specifically has on board a default behavior of doing all that like data whitening and everything. You could totally, like it implements retries and stuff, I think, if I understand correctly, on the chip itself. So if I wanted to send you a packet and reliably get it to you, I wouldn't necessarily be using all of that configuration that I sent to you. That's specific to make it talk to these other chips. But like those 2 RFM chips could talk to each other out of the box with less configuration, like the default configuration would work fine for them. And then they would have like retry of the packets if nothing got ACKed or something like that. It's basically like a hands-off control mechanism where I can make sure that a message gets to you. Yeah.
That's super cool.
But I don't really know how to use that because that's not the world I've been living in. So. Yeah, there's like network numbers and node numbers and broadcast addresses, promiscuous mode. Like there's all kinds of really high-level stuff implemented in like a low-level chip, and maybe partly in the library on the SparkFun side for Python or whatever. But yeah, so like $15 I think was what I paid on average between the 2 for the Adafruit and the SparkFun one, and you can just go on their website and buy these things. It fascinates me how good the documentation, how good these chips are, how cheap they are, and I mean it's pretty reliable. Stuff just kind of works. And that's just with wire whip antennas. Like I just measured out, I think 82 millimeters, and just soldered it onto the antenna part of the board. You could get a lot better results, I bet, with a better antenna. But that's exciting. So no game. You can just send me messages. That's better. Anybody have any questions about this stuff? I think when they come out with the boards, so the boards that they're developing, one of them in particular has this chip, the RFM chip. It has a battery charging circuitry, like it has a battery controller for a LiPo battery. It has a real-time clock and the ability to be scheduled to turn back on the Raspberry Pi. So if you're building, for instance, a Nerves application that has a duty cycle of like 30 seconds out of every 5 minutes, you could have it boot up, go right into the Nerves application, do whatever computing or communication over that radio chip that you want, and then tell the real-time clock chip, I would like you to wake me up in 4.5 more minutes or whatever, and then basically just call system.halt and just shut down completely, and the battery connection to that real-time clock will stay active even though the Raspberry Pi is completely disconnected from power, and it'll turn it back on, and you can do whatever it is that you want to do. So if you have like a gardening project or something like that where it's outdoors and you don't have easy access to power, like there's a lot of really interesting opportunities outside of what he's actually designing it for that would make it kind of a fun little project board. It also has an accelerometer. I just haven't figured out. He said it's for like input, so you can like shake it once and it's like that means something, but I haven't really figured out exactly how I would use that effectively. The other board is using this other Texas Instruments chip and has like a little OLED display on it, and I want to say some buttons and some things like that that you can use to interact with it. They showed a demo of it joining a Wi-Fi network that was unsecured by like basically mousing to it and hitting enter. So there's a lot of really interesting stuff for these boards, but I'm really interested in the chip itself that talks to the insulin pump. So I think that's really all I got. And nobody's sending me more messages, so I think you. Oh. He's trying to drop my database still.
It's a really good one too.
Is it, see, what I haven't really tried a lot is the multi-packet part of either of these libraries, because the packets themselves for the pump are either 64 bytes or like 200 and maybe 55. I don't know exactly where it falls. But once the message gets really long and it has to break it up into multiple packets, like multiple frames, I don't know what it does.
Yeah.
So it probably crashes is what happened. Try it again. Is it still sending?
Yeah, I think I did.
I'm going to sneak over and look at what you're doing.
Ah. Really? Why? No, that's just over. Yeah. Okay, so then.
You've got like an ASCII animation just by scrolling.
Mm-hmm. So yeah, I should be able to do.
Just make sure you null terminate it.
There you go.
You crashed a gen server.
Yeah.
Good
that's
times.
My gen server.
Yeah. Mine's fine. Everything's fine over here. See, I just got some paragraph marks and
How do you scroll on the screen? Control shift.
I don't know. I'm not sure. It might be like shift page up or something. I like what you were doing there. I got the first line of it. It was amazing. What if you sent each individual line as a separate?
It did do a new line.
What if you sent each packet or each line as a different packet?
Oh, I could do this. Yeah, sure. Yeah. So, macro,
Maybe Alex was messing with you. Maybe she was hacking and transmitting at the same time you were, just for fun.
You're never even gonna know.
Yeah. The fun thing about being on these unlicensed bands is like basically everything works on them. If you've ever had like a ham radio or something that can listen on 900 megahertz, you can actually listen to the baby monitors of your neighbors and stuff, and it's really creepy and messed up. Most of them have gone to like spread spectrum and don't use just regular transmission anymore. But
just put their baby monitor on the internet.
yeah, now they're hackable by IP instead. Yeah. Yeah.
The S in IoT stands for security.
I see what you did there, James.
So how do you find this stuff? Do you just like browse hardware boards and?
Yeah, kind of. That's almost, it's almost exactly what I do. Have you been stalking me?
You left your baby monitor on.
That explains it. So there's a hardware development channel in OpenAPS where they're talking about the board development of the different chips that are working. There's also a Google group. And there's a few people who have done very specific work in these areas already, so I'm not the smart one who figured out all the configuration parameters and the magic bytes to send to the thing to get it to work right, but I gotta remember. Yeah, so there's like a board basically where people are talking about possibilities of like, can we use Bluetooth for this and all of that, and these two specific boards have kind of come out of those two forums.
And then you then applied the nerves technology to the programming on it?
This is risky. I'm going to Instagram. Let's see what happens. So these are I just wanted to get a picture of the boards. So once I figured out the pinout of the different boards, because they've got like some open specs on which pins are the reset and the interrupt pins and all that, I just prototyped it. So I spent a little time in the basement soldering to the right headers, and these are really cheap prototype boards you can buy from Micro Center. So basically just figuring out the wiring and then making the chip that I bought from Adafruit look like the chip's going to look when it's on the actual commercial board, and playing with it until it works. That's what, a lot of trial and error is basically with the way I've been doing it.
I exited in write burst 40.
Yeah?
Um,
That sounds fun.
16 byte return on a timeout 5,000. No process. The process is not alive. There's no current process associated with the name.
I bet the gen server crashed before. Did you start the link again? All right, so that's really all I got. I'm going to stop the stream, but I have some code that I would like to run, maybe write.